Hi, I'm an old guy and I do maths. Today our problem is to find the inverse of this function, which is a hyperbola. Um, now, those of you who've seen other videos in this playlist about finding inverses will note that in an earlier video I set out to find the inverse of a hyperbola, and I don't know whether it was to everyone's surprise or not. Turns out to be a hyperbola. It looks different, but it is still a hyperbola. And that's, generally speaking, what the outcome is. So we've got to find the inverse of this hyperbola and graph it, and then figure out where, obviously because we graph it, where it intercepts the original. So where does the original function intercept its inverse? So let's get into that. So there are a number of tasks to perform. The first of which is to find the inverse, and this is the start of the process here. So here is our equation: y equals 1 over x plus 3. And to find the inverse, all we do is swap the position of the x and y. Now, that is technically speaking the inverse of that, but mathematicians being what they are, they like nice, tidy solutions. So what we then have to do is we have to make y the subject of this again. So what we want is we want to be able to line up y equals something with y equals something and say that each is the inverse of the other. So a tiny bit of work to go on there. This is the next step. We just move the 3 over to here. X minus 3 equals 1 over y. And then we can swap the position of these two, and what we get is this as our inverse: y equals 1 over x minus 3. Okay, so that's our inverse. So let's just note that. We'll pop that here. Y equals 1 over x minus 3. And the original was y equals 1 over x plus 3. So you can see and get a little bit of a feel for the difference between these two. Each one is the inverse of the other. Now, there is more work to do. And what we've got to do is we've got to find out where these things actually intersect each other. But first of all, I'm just going to do a quick drawing so that we can see what these things look like. Now, I'm going to do one in blue pen and one in red pen. The first one I'm going to do is this. I'm going to do it in blue pen. Now, this has two asymptotes. One is the y-axis, and the other is here. This is not to scale, please note. This is y equals 3, so please remember it's not to scale. And this is a positive hyperbola, so it looks like this. And this one, this part of it, looks like this. So it has an x-intercept. We're not interested in the x-intercept. What we're interested in is where this intercepts the graph of this, and we can draw it. It's very easy to draw. So because this was the y asymptote, it now becomes the x asymptote, and so the x asymptote is here at x equals 3. And it's this line here that now becomes the other asymptote for this. So let's just see what this looks like. Okay, so let's go to work. These are both positive, and so what we expect is the following. So there we are. That's a point of intersection there, which we're going to have to work out. The other point of intersection, this is an asymptote for the red graph. It's going to go through there like that, and we've got another point of intersection there. So I hope that's all plain. So let's just go through this again. This thing has an asymptote at y equals 3, and it's a positive hyperbola. So it looks like that, and it looks like that. The other asymptote is the y-axis. Because this is its inverse, the asymptotes are reversed. So y equals 3 is now the asymptote x equals 3 for this. And the y-axis used to be the asymptote, or is the asymptote for this. Now the x-axis is the asymptote for this. And these two things hit each other here. Now, how do we figure out that point? Well, that takes a tiny bit of work, and so let's get into that. Okay, so we have two equations. Just let me find my blue pen again. We have two equations. 1 over x plus 3 and 1 over x minus 3. Now, where do these things intercept? How do we normally figure out a point of intersection between two graphs? Well, we construct a simultaneous equation, and we simply equate these. So with without too much effort, we can get to this point. Sorry, that should be minus. Just ignore that. That should be a minus 1 over x minus 3 equals 0. Okay, well, that's kind of exciting because we're now in the world of fractions. A little more tidying up. 1 over x. We'll put the 3 out the front. We'll just reverse the position of that. Minus 1 on x minus 3 equals 0. So I hope you can see that clearly. All I've done is move that out here, and I'm going to make that 3 over 1 so that you can see that we're dealing with fractions all the way along here. Now, what I'm going to do is I'm going to put these things together, which means that I am subtracting fractions. So it's the old story of cross multiplication. So I'll draw a rough line there, and that is x minus 3, and that is minus 1 into x. I'll just get a new pen because the ink in this is running out. 1 over x, and I multiply the denominator, so that is x into x minus 3. And when I tidy all that up, I have 3 over 1 plus this expression here equals 0. That's a 0. Okay, so there's a bit of work in this, but if you're methodical, everything will turn out okay. So 3 plus this works out to be x minus 3 minus x all over x squared minus 3x, and that all equals 0. Now we can tidy this up. We can get rid of this denominator simply by multiplying everything by x squared minus 3x. And what we get is we get 3x squared minus 9x, so that's that times that, plus x minus 3 minus x equals 0. And if we tidy that up a little bit, we get 3x squared minus 9x minus 3 equals 0. If we solve this equation for 0, we will find the x values of the points of intersection for this graph. So that's what all that work is in aid of. So we can do a little bit of tidying up here again. We get x squared minus 3x minus 1 equals 0. And what we're going to solve is we're going to solve that. And we're going to do that using the quadratic formula because an answer doesn't leap out at me. And so let's just get to that now, so that I don't make any mistakes with pluses and minuses. I did this earlier. So here's our equation. We'll make that equal 0. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So b is negative 3. That's a b, not a 6. We'll just make that clear. B squared will be 9. 4 is 4. A is 1. And c is negative 1. That gives us a positive value here. When we tidy this up, this is what we get. X is equal to 3 plus or minus the square root of 13 over 2. This x value here and this x value here we have numbers for, and that is 3, I imagine, minus the square root of 13 over 2, and this will be 3 plus the square root of 13 over 2. You can pop that into your calculator and get the y value. I think this video has gone on long enough, but that is how you do this. So let's just recap quickly. Find the inverse. We swap x and y. We were instructed to graph these things, so what we know is that the asymptotes swap around. The blue graph is this equation, the red graph is this. They intersect at 2 points. In order to find those points, we make this equal to this, and the working for that is here, and it's simply the most complicated part of this. The stuff that would throw people, I suspect, is the subtraction of these fractions here. Anyway, once we get through that, we get a quadratic, which tells me that there's possibly 2 solutions, which is great because our graph here suggests that there are 2 solutions. We can simplify this a little bit, pop it into the quadratic formula, and we get a value for x. We can then take that value of x, if we are so minded, and put it into this equation and put it into this equation. Let's get that right, because there is a dilation factor here, and get a value for y. Okay, well, I hope that you found that useful and interesting. It's fairly long, but if you did find it useful, please like and subscribe, and I'll see you next time. Bye.